Hi, the topic of today will be about roots and fractional exponents. So in this video we are going to start with a reminder about the square root and the cubic root. Then we'll define what is a root to be able to link the exponents with the root. And we will see what are the properties of the root. And finally we will consolidate our new knowledge by doing some examples. And we'll conclude this lesson after that. Let's look at the square root. So let a be greater or equal to 0. Then x squared is equal to a admits two real opposite solutions. What I mean is that if you have something, then we have also minus something. They're opposite on the real number axis. So if a is equal to 0, then x2 is equal to 0 admits a unique solution, which is x is equal to 0. So now let's do some examples. So if you have, for example, the square root of 2, it will equal 1.4142 etc. with an infinite decimal development. And then for other number, you have a solution which is an integer. For example, square root of 4 is equal to 2. Small warning. So you may have noticed in the previous example that we only had one solution for each of our example. So the reason is that when we apply the square root, we only take the positive solution. So this is simply a convention. For example, when I say square root of 9, the answer is equal to 3. Now for the cubic root. So the cubic root of a real number, is the unique real solution to the following equation. X to the 3 is equal to a. So here are some examples. Which number is equal to minus 8 if you multiply it by itself 3 times? The answer is minus 2. Now, which number multiplied 3 times by itself give 27? The answer is 3. So let's define the root. So let a be greater or equal to 0. Then there exists x greater or equal to 0 such that x to the power of n is equal to a. So this real number is called the nth square root of a and is denoted in the following way. So in this term, there is three things that are interesting. The a, the symbol of the root, and then the n. So these have some names. So in red, you have what we call the endis, and then in yellow, you have the radicand, and finally in blue, you have the radical. What is interesting in our case is n, because it can be either odd or even. So let's analyze this case. If n is even, then the nth square root of a is equal to x. If a and x are greater or equal to 0, so you have to have some condition. But for the other case, if n is odd, then the nth square root of a is equal to x if a is a real number. So in the second case, it's really more flexible. So you can see that the square root and the cubic root are some particular cases of this general definition. Don't forget that for even value of n, we only consider the positive solution. So let's define the fractional exponents. So here it is the case that we had previously. So the goal is to find an exponent p such that a to the power of p and all that to the power of n is equal to a. So if we find p, we found a way to express the nth root of a. So how do we do that? So here are some simple steps that we can do thanks to the exponents rule. So a to the power of p, all that to the power of n, you can multiply the exponents. So that gives a to the power of p times n is equal to the a to the power of 1. So that implies that p times n is equal to 1. And now what you can do is simply isolate p, which gives p is equal to 1 over n. And of course, n is a natural number which is different from 0. So this is well defined. So let's revisit the past. We already saw the exponents property. So let a and b be some real number which are invertible, and m and n be some natural numbers that are different from 0. Then we had the four following properties. So the idea is that because I've been able to express the roots as some fractional exponent, we can develop our own property for the roots. So let a and b be some real number, m and n be some natural number different from 0. Then we have these 4 new properties. So the first one is simply related to the fact that you can add the exponent. So here what you can do is you simply add the exponent together. You obtain 2 to the power of 5, 6. Then for the second one, it's just that you can put the square root over the fraction. So here you have 200 divided by 25, which gives 8. Cubic root of 8 is equal to 2. For a third one, the trick is that because you are creating a common root, you can just introvert m and n. So you introvert the roots. So now the key is that you have cubic root of square root of 16. Square root of 16 is equal to 4, so it's cubic root of 4. And then finally, for the last one, you can just split the expression. So here 18 is equal to 9 times 2. You can just split it into 2 square roots. So square root of 9 and square root of 2. Now it's give 3 times square root of 2. So here are some examples that you must try to do in order to consolidate what we just learned in the previous scenes. So simplify the following expressions. So here are 4 expressions that you must simplify. So go ahead, pause the video and find the solutions. So if you found the solution, congratulations. So here are the solutions respectively. So square root of 14, 7, 100 to the power of 7, 12, and then 1 over 8. So let's simplify these expressions. So for the first one, it's just 17 minus 3. Pretty easy. It gives 14, so square root of 14. The second one is a little bit more complex. So you split the fraction. The square root of 25 can be simplified in the first one. So you just obtain 3 for the first part. For the second one, you just factorize 80, which is 4 times 20. And then you can cast out the 4 from the square root, which gives 2. So you have 2 times 2 times square root of 20. Then you can simplify the square root of 20 in the numerator and denominator. 3 plus 4 is equal to 7. Third one, you just have to add up the exponents. It give 100 to the power of 7, 12. And then finally, you just have the last one. So for the d, it's 4 to the minus 3 divided by 2. So what you can do is that you do 4 to the power of minus 1 half. Then that to the power of 3. But then you can simplify it. And then what you obtain is simply 1 over 8. So to conclude this lesson, we'll just review quickly what are the important elements of this lesson. So first, we provided a definition of root. Then we did the link between exponents and roots. We also analyzed the root properties. And last but not least, we saw how to simplify expressions with the properties of roots. So this is all that we have to see for this lesson. Thank you. See you next time.